Today, we present to your attention a report on the topic, Increasing the Reliability of Welded Joints in Trucks by Modeling. One of the most essential conditions for ensuring the competitiveness of the automotive industry is maintaining the specified operational reliability of vehicles, which, in particular, concerns damage that requires the use of repair actions using welding. In the context of digitalization of all areas of activity, the automotive industry uses methods of modeling products and processes at all stages of the life cycle, including at the design stage, which allows increasing the operational reliability of vehicles, as well as improving the main technological processes of production and repair. Welding of metals is widely used in modern technology and is considered one of the most significant technological processes in many areas of mechanical engineering. In many cases, welding is a more effective or the only possible method for creating permanent connections and obtaining resource-saving blanks that are as close as possible in geometry and optimal shape to the finished part or structure. Due to the complexity of designing welding technologies, today there is no specialized system in mechanical engineering that allows automating the process of developing technological documentation for welding. Basically, existing systems only allow automating the process of storing and using technology as a document. In other words, they allow simplifying document flow at the enterprise. However, such systems do not provide any assistance in developing the content of technological documentation, which does not eliminate the main drawback of the process of designing welding technologies: the influence of subjective characteristics of the technologist on the quality of the technological process he is developing. Reasons that make it difficult to ensure the quality of welding work. Technological services work according to traditional old reference books, which does not allow specifying welding modes, leads to uncontrollability of processes and the impossibility of influencing quality. Inaccurate determination by technological services of the locations of technological strips, spacers, inaccurate design of the sequence of execution and the length of welded seams, which leads to large residual stresses and deformations in structures after welding. Low qualification of personnel performing welding work. The quality of welded structures can be improved by using modern methods of computer modeling in the technological preparation of production and repair. The use of the developed automated design systems allows to reduce the labor intensity of developing one technological map of the assembly welding process by 8 times, to reduce the cost of wages for the development of each technological map by 10 times, to reduce the cost of developing one technological process map by up to 15 times, allows to significantly improve the quality of the documentation being developed, and to sharply reduce the dependence of the quality of the documentation on the qualification characteristics of the designer. Virtual modeling allows to significantly reduce the number of full-scale experiments by replacing them with fast, efficient and highly accurate computer modeling based on the created virtual models. Detection of defects at the stage of development of the technological process. Acceleration of the process of introduction of new parts into production and reduction of costs. All these are the goals of computer modeling of welding. To substantiate the relevance and importance of the use of modeling of the welding process in large-scale production, it is proposed to consider a specific case of modeling. The fuel tank bracket has a defect of warping of the structure after welding, which leads to non-compliance with the design documentation requirements. We need to model the welding of the fuel tank bracket, compare the modeling results with measurements, and make suggestions for improving the process. The modeling process in the program is divided into 4 stages: building a grid of elements, setting the welding process, carrying out calculations, displaying the modeling results. As a result of the process, modeling analysis. It was revealed that due to the close location of several welds, temperature fields overlap, which leads to significant deviations in shape. The modeling result with the revealed distortion of the product shape is shown on the slide. Changing the input data for modeling the bracket required repeated modeling. As a result, correct modeling of the bracket welding process was achieved. Recommendations for welding are: change the order of creating welds, and strictly observe the welding direction. Avoid using rigid fastenings during cooling. Fixing the part will prevent shrinkage deformation, but will cause stress in the fixed areas. It would be possible to avoid large costs for the production of the product we considered, if the modeling was carried out at the stage of developing its 3D model and writing the technological process for its production. The second weld joint case study concerns a component that impacts driver safety. The average truck driver spends more than 40 hours a week behind the wheel. Such prolonged sitting results in musculoskeletal disorders, soft tissue damage, ligament strains, and muscle strains. Drivers often cite ergonomic issues related to getting in and out of the cab or discomfort during long-term vehicle use. This will ultimately lead to ergonomic injuries or worsen existing conditions. Getting out of the truck can lead to injuries if drivers do not use 3 points of contact. When getting in and out of the cab, a low step and a flat cab floor improve the driver's daily work and make it more comfortable. Many truck drivers are injured each year due to falls when getting in and out of the vehicle. Simulation allows assessing the suitability of steps and handrails as a system, since driver health problems affect the safety of other vehicles, cargo safety, and the quality of transport and logistics processes in general. Automakers are taking steps to include real-time driver health monitoring in the vehicle system. Currently, there are many tools that allow you to determine many indicators of a technical system at the design stage without resorting to expensive experiments. These are strength and dynamic characteristics, various parameters of the system's operation, including ergonomic characteristics. There are software tools that allow you to select the most suitable design solution at the design stage that can provide a safe and ergonomic working environment, and also, if problems are identified at the operational stage, find an option to adjust the design to solve the problem. For example, footrests are an important component of the cabin ergonomics, as they provide safe access to and exit from the cabin. The design of the footrest support includes brackets that, as established during operation, have a defect in the form of warping of the structure, which leads to harmful contact and damage to the paintwork of the front wing of the car when the cabin rolls over, which can subsequently lead to destruction of the structure and injury to drivers. The slide shows a 3D model of the cabin with the installation location of the footrest support bracket, as well as the design of the bracket itself. Since the cause of the defect could be defects in the welds, it was decided to conduct a simulation of the welding process in the as-is mode to identify problem areas and develop recommendations for improving the process. The following were used to model the process: a 3D model of the construction part, design documentation indicating the material of the part, a description of the process with the order of fastening and creating welds. After analyzing the results of the process modeling, it was found that due to the close location of several welds, temperature fields overlap. This leads to significant deviations in shape. The general nature of the warping of the structure is shown on the slide. Based on the simulation results, recommendations were formulated to improve the welding process of the footrest support. Consider the possibility of manufacturing the structure using a modular principle. Use a different welding technology for the footrest support. When designing welding equipment, avoid planning hard-to-reach seams in the product design. When welding the structure, avoid cross seams. The longer the seam and the larger its cross-section, the greater the amount of warping. Provide forced ventilation of the structure in the technology. Avoid using rigid fasteners during cooling. After changing the technological process, modeling was performed, as well as a design check for manufacturability. As a result, it was established that the design parameters had improved and met the requirements. The formulated recommendations, after the necessary approvals, are reflected in the technological process of manufacturing the product, which is a guarantee against the recurrence of the defect. Given the current level and pace of development of industry and technology, issues related to development, design and production require equally fast and modern solutions. Improving the quality of decisions taken, eliminating errors at earlier stages leads to a reduction in costs at subsequent stages, especially at the stages of implementation and production, and ultimately to a significant reduction in the cost of the entire project. Improving the welding process will increase the reliability of the truck and the safety of operation. Thank you very much for your attention.